Hey everyone, so in last video we saw a multi-agent architecture and there was a critical component in that architecture called MCP, and as discussed in that video I have made a MCP client and made several connections, several MCP server connections with that client, and that's running in my local. I'll explain that project and how I have built it. But before that, let's get a quick intro of MCP protocol, so what it is and why it was built. In a simple words, MCP is open standard protocol for AI applications or LLMs in simple words to connect with external data or external systems. So before MCP, LLMs or AI applications, there was no standard way to connect with enterprise data, and because of that, enterprises had to build different connections for different AI applications, which was making very hard to maintain. So for example, if let's say Atlassian has Jira software and Jira data, and there is a AI application or agent that has to connect with the Jira Jira portal, and it has to list down the Jira task or issues there. So there was if we have to make this establishment, then Atlassian has to build like one connection for each of the AI application or agent. So if there, let's say there are 10 agents that need to access uh, this data of the Jira, then Atlassian has to build 10 connections. And let's say inside the Jira side, if you have like 20 tools or 20 APIs, then they have to make one connection or one connector for each API. That will make n into m connections. So you can imagine like how many connections it will become and how hard it will become to maintain. So that's why, because that time we were doing function calling for LLMs, and each of the connections was a function tool. So there will you have to maintain, one function calling tool for each of the connections, and that was very hard to maintain. And because of that, there was a need to have a standard, protocol which can be used between the AI applications and the enterprise softwares to make to make them seamlessly access the data, and agents can work on use that data to build smart workflows. So considering that, Anthropic came up with this protocol, and this protocol become famous in very short time. As this in this example, you can see if there are three tools in the left hand side, three AI applications or agents, or let's say your own agent or any enterprise agent like Claude or uh, or any other tool. So for each of these tools, without MCP, the data sources in the left hand side has to build a one separate connection, and that will become, let's say, nine connections just for these three examples. And that nine connections only if there is just one tool in one API in each of these data sources. But what if they have like n number of APIs? So it will become n into m connection, and that will be very hard for to maintain for the enterprises. So MCP came in picture, and you can see what it is solving is it is providing a USB-C port kind of thing for between the AI applications and the data sources, where for these three AI applications to connect with three sources, we just have one connection for each of the each of the AI applications. So it's making a lot easier for the AI application to connect with enterprise data, and that's what the power of MCP is, and that's why it is used a lot now to build agents and build agents for on top of enterprise data. So it's written here as well that it's like a USB-C port for AI applications, similar to how we connect electronic devices with our laptop or any other system. You don't need different wire or port for different device. You can have a single USB-C port which can connect with different electronics device. Similar way, you can just have one MCP protocol to connect several different AI applications with a single enterprise data source. So that's what the MCP is. Let's talk in brief about its architecture. So MCP has three main components. One is MCP host, then client, and the server. So MCP host is any AI application. Cloud desktop can be one host, cursor can be one host, client can be one host, codex can be one host. So all these are host. Host means host simply means AI agents, which has workflow in it and which are using LLM. So these host is simply AI agents. Then coming to client. So what is client? So client is, you can say, it's a piece of it's a piece of software, or you can say it's a component that is capable of making handshake with the server, and it is built using the same standard protocol, and it will be able to make connection with the server, plus also it will be able to exchange certain data with the server, and we call them lifecycle events between client and MCP client and MCP server. I'll talk about those steps, what exactly happen when an AI agent tries to connect with the MCP server using a client. So there are a lot of steps happen between the client and server. Data exchange happens, and that we call life cycle, and that is very critical to understand if you want to build any MCP server and want to make an agent on top of it. So you can see here, like, there can be many clients which can connect to a single MCP server, or there can be a dedicated connection between client and server. When this connection happens, there are certain events happen, and let's talk about those events because those are important. So uh, the main event that happens between the client and server is, the very first step that happens is initialization. So when the client starts connection with the server, the first step is initialization, and in the initialization, the payload request that goes to that goes to server from the client side looks like this. It's a JSON RPC 2.0 request, and method name is initialize. So why initialize happen? Initialize is a way for client to understand the capability of the server, plus also understand what version of MCP is used in the server side, and is the client and server compatible enough to talk to each other. So in the initialization phase, the information exchange that happens between client and server is protocol version exchange, because MCP is a protocol and client and server both should have compatible versions. So protocol version exchange happen, and then capability exchange happens, means server tells about his capability, what are the tools it has, what things it is capable of, so that client has full understanding of the power of the server, and that comes under the capability. And third is client info. So server should also know about client, its client's version, and what are the client how the client has been built, because server does few things in this life cycle event on the client, and for that server need to know the client info. So in nutshell, few things happen in the initialization. First is your protocol version. Client and server get to know about each other's protocol for compatibility. Then server tells about its capability, what are the tools and what are the capability it has, so that client should get to know about it. And then client information is shared to the server so that it knows about the client capability, and whatever events it has to execute on top of client during the lifecycle, that it can do easily with the client info. So after the initialization phase, there are certain other events happen, and those happen by the server on the client. So these are the three important things that happens from the server to the client side. And many people might be knowing that, I mean, they have understanding that only client can request tasks on the server, but in this MCP client server workflow or lifecycle, even server asks certain things to the client, and those things are important in this workflow. So first thing that happens is sampling, and the second is elicitation. So sampling is something where server asks the client to execute certain prompt on the LLM which is present in the client side. So for example, let's say there's a AI agent that's for travel booking, and that AI agent has requested server to get top three flights for a certain location cost wise. So what server will do, server has certain tool to fetch all the flight data from the airline database. Once it fetches all the flight data, and it has all the data, but it don't have intelligence or LLM to decide like what are the best flights cost wise for a certain location. So what server will do, server will make a sampling request on the client, passing all that data and asking client, hey client, can you use this data and you use your LLM to find the top 3 flights out of these data. LLM will execute that request and it will give it back to server, and then server will give it back to the agent again. So that's what sampling is. Sampling means basically server can request certain actions to be done by the LLM which is running on the client side. And the benefit of this is, in this whole workflow there will be more security in if sampling is happening, because when server requests certain actions using the LM which is running on the client side, user can come in picture using human in the loop, and user can have a approve step where if server is requesting certain action to be executed by LLM, there will be a human in the loop approval request where human can approve or deny whether that request can be executed by LLM or not. So that way it is making more secure the end-to-end workflow. And second kind of thing which happen from the server on the client is elicitation. So in the elicitation, let's say there is a this same flight booking agent is there. So if the flight booking agent is sending a certain request to the MCP server, and MCP server has to execute that request. Before executing that request, let's say the agent has requested to book a flight. So it's a final step where MCP server has to execute a tool which can book the flight. So this is a critical step because it involves cost of the user. So what MCP server can do, MCP server can send a approval request on the client side, which can be seen by the user, and it can say that I'm about to book this flight. Please approve or deny whether you agree or not. So this is called elicitation, where server can request certain events on the client for, let's say, human in the loop approvals or other kind of human intervention. So that's called elicitation. And then logging. So servers also log whatever happening on the server. They can log those messages on the client so that the user who has control of the client, the user can see all the events transparently for debugging and monitoring purpose. So these three important things happens from server side to the client side in this MCP lifecycle, which many people don't know. They think that only client can send actions on the server, but in reality, even servers do these things on the client in MCP lifecycle. That's why security is very important in the MCP workflows, because server is also executing certain things on the client. Okay, so this is the main things in the life cycle. And then if you talk about what are the main layers in this MCP, the two main layers in the MCP are data layer and transport layer. So what are the data layer and transport layer? So when this MCP client server communication happens, there are few important data modules that happens that gets exchanged between client and server. So first is the tools. So whatever tools present on the server, client request all those tools as a schema, because those schema tells about how to execute those tools, what parameters are needed to execute those tools, what are the description of those tools. So tool description is something which is in natural language. It tells about what this tool can do. So all this tool schema is requested by client from the server side, and it is basically stored in the client side, and that comes under the data layer. Then resources and prompts are other two important entities which the server sends to the client, and these are also cached in the client side, and it's used by LLMs to decide these tool executions when an actual query comes in the agent. Then lifecycle management data, because as I explained, these all things happening between client and server. So lifecycle management data is also stored in the client side. So these were the data part, and then second is the transport part. So how is communication happening? What is the communication channel between the client and server? That comes under the transport layer. So in the transport layer, main things happen is what is the message structure that will happen within the client and server. That is mostly JSON RPC 2.0. I'll show some of the examples what kind of payload it looks like. Then uh, what are the two protocols that is used to connect between client and server? So the two main protocols that are used to connect between client and server in MCPs, one is stdio and second is streamable HTTP. So stdio is mostly used when the MCP running in your local machine. It's for local MCPs, and the communication between client and server happens through your local processes in your own machine. Local stdio means basically input output streams that are bidirectional between your client process and the server process in your machine. So it's simple stdio and input output streams. Through input output streams, client and server talk to each other, and all transport data stays within your machine itself. So that's why local stdio is more secure. uh, Second is streamable HTTP. So streamable HTTP is for remote MCP servers. In this protocol, client sends a HTTP post request to the server, which is running on a remote location. And the message structure that happens between the client and server is JSON RPC. It is mostly HTTP post call. And you also need to the authentication is also HTTP authentication, which happens using bearer token or API keys or custom headers that is decided by server itself. So server will decide that what kind of authentication it has to impose. Client has to basically procure those API keys and bearer tokens, and build the header as per server requirement and make the HTTP post request. So these are the two protocols. One is for local MCP, other for streamable HTTP, which is for remote MCP servers. So yeah, and the message format that happens in this protocol is JSON RPC 2.0. How it looks like, let me show you how it looks like. So if you go to tool call section, so it looks like this. You have JSON RPC 2.0, and there's ID. ID is basically uh, used to give identity to this whole session of message exchange. And then there is a method. So method can be tools list or tools call. These are two methods. There are other methods as well, like resource tools slash resources or tools slash prompt. So those are to fetch prompts or resources, especially to execute the tool or to fetch the tool data. List and call is used. So if you call this tools list, it will get all the available tools schema which are present on the server to the client. And if you call tools call, which is here itself, so you need to give tool name as well, plus tool arguments also. So this, what it does, it executes the tool on the server, and server respond back with the data of the tool execution. So response wise it will look like this. But if you go to list tools, that will not give you data, but that will give you the tool information or tool schema, which can be used by the LLMs to decide what parameters are needed by the tool. So you can see it is giving all the tools schema, the structure, and what parameters it needs to execute it. Also tool description, this is very important. It's used by LLMs to understand what this tool is capable of. LLMs match this information against the query which is coming, and based on this comparison, LLMs decide that this tool is fit to be called for that query or not. So whenever you are building MCP server, making this description unique, compact, and uh, perfect is very critical, because if there is any overlap between the tool description, two or multiple tool description, then LLM will not be able to decide that which tool should be called for a particular query, because uniqueness of the tool description is very important. So tool description should be unique, and it should not overlap with other tools. Then input schema comes. So input schema talks about what are the parameters that are required to be sent from the client side to the server to execute this tool. So this tool basically needs two parameters. It can see like it will show the type of the tool plus description of the parameter here it's showing. So yeah, so I think that's how tool call and list tool call and list tools happens. There is one more thing which is important in the client server communication, that's called notification. So whenever communication is happening between client and server sometimes there some change happen on the server. Let's say some new tool get added on the server, or let's say some capability of the server has changed, And if client is not aware about it, then communication will break. So during initialization of the lifecycle itself, server can tell to the client whether it is capable of sending notification or not. If it is capable of sending notification, then in the initialization response, it will tell that uh, that notification capability is true. So I'll show the initialization response, how it looks like. Uh, see here. So you can see initialization response. In this response, there is one more parameter which is not showing here called notification, and that becomes true if server is capable of sending notification to the client. So if server is capable of that, then if any change in the tool or anything happens on the server, any change, that will be communicated to client immediately by the server, and then as a response, client can call list tool to get the updated list of tools with updated parameters. So you can see client respond back with the whenever notification come from the server side, client respond back with this kind of request. It basically requests the server to give the updated set of tools to it, because any change is happening, client should know about it. So that's notification, and with that I think I have covered everything of the MCP architecture. In the next video, I'll explain the project that I have built, the MCP client, and how I have connected different MCP servers with that client. So with that, let's see in the next video.